This is Mr. Martin. These are video notes for section 8.6 for Precalculus Honors. We're just continuing here with the notes. This is video number 2. So let's get right into the examples. Again, if you want to try these on your own as you go through, just pause the video and you can restart it to check your work and your answer. So for number 11, we're forming a 10-person committee from 9 women and 12 men. The committee must consist of 5 women and 5 men. So how many different 10-member committees are possible? So we really have 2 events here. We're choosing 5 women from a pool of 9, and we're choosing 5 men from a pool of 12. So the order that we pick the women and the order that we pick the men really doesn't matter, so we're going to have combinations. So for picking the women, we have 9, and we're going to choose 5. And for picking the men, we have 12. And we're going to also choose 5, and then we would multiply these 2 events together to get the possible committees. So 9 choose 5 would be 9 factorial over 5 factorial times 4 factorial, and 12 choose 5 would be 12 factorial over 5 factorial times 7 factorial, which would be 126 times 792, or 99,797 possible 10-member committees. Alright, so moving on to some more examples. Again, if you want to pause, and then you could restart to check these. These are kind of all mixed up, different kinds of examples. So a restaurant offers 4 sizes of pizza, 2 types of crust, and 8 toppings. How many possible combinations with 1 topping are there? So we've got 4 sizes, 2 types of crust, and 8 toppings, so we have to pick one of those. So we have 4 choices for the pizza times 2 choices for the crust times 8 different toppings. We can only pick 1 topping, which would give us 64 different pizzas. Alright, number 2, how many ways can 5 paintings be lined up on a wall? So this is orderings of things, so we can either do that as 5 for the first spot on the wall, times 4 for the second, times 3, times 2, times 1, or again, this is 5 factorial, which would be 120 ways to arrange the paintings on the wall. Number 3, Rob has 4 shirts, 3 pairs of pants, 2 pairs of shoes that all coordinate. How many outfits can he put together? That's going to be 4 times 3 times 2, or 24 outfits. And number 4, Grace loves to eat salad. How many salads can she put together if she can pick out 1 type of lettuce from 2 choices? So 2 types of lettuce, 1 vegetable from 4 choices, and 1 dressing from 7 choices. So 2 times 4 times 7, or 56 different salads. Alright, number 5. Pennsylvania license plates have 3 letters followed by 4 numbers. If the same letter or number can be repeated, how many can be made? So 3 letters, so that's going to be 3 spots where we have 26 choices for each, since we can repeat them, and then 4 numbers for the next spots, and there can be a possibility of 10 different numbers for each of those. And if we multiply these all together, we're going to get 175,760,000 different plates. Okay, now for part B, if the same letter cannot be repeated, how many can be made. So now for our spots of letters, we're going to have 26. Whatever letter we use there, we can't use for the next spot, so we only have 25 choices. We used one more letter, now we only have 24 choices. And then our numbers are going to be the same, so that's 10 to the 4th, 10 to the 4th, or 156 million license plates, so considerably less. Different plates. And then for number 6, we have how many 5-digit numbers can be formed using 0 through 9. So we're going to have 10 possibilities for each 5-digit number, which we could write as 10 to the 5th. That's just 10 times 10, 5 times, or 100,000 5-digit numbers. Alright, again, if you want to work it out, using your 5 different spots, we have 10 possibilities for each one. We're going to multiply those together to get 100,000. Now for number 7, how many 5-digit numbers can be formed if each one uses all the digits 0 through 4 without repetition? Okay, so now again we have a 5-digit number. So we have 5 possibilities for the first one, times 4 for the second, times 3 for the third, times 2 for the fourth, and 1 left over for the last spot, which again is 5 factorial, or 120 different numbers. Alright, number 8. In how many ways can 6 bicycles be parked in a row? So we're ordering 6 things. Again, we can do this in 6 factorial ways, which is 720 ways. Let's see what else we've got down here. Okay, so it looks like that's it for these sets of notes. So we'll stop the video here and continue these on in the next packet. Again, if you have any questions, make sure you ask. Follow along with the syllabus so you're working on the problems from the textbook as well. And we'll see you next time.